In this problem, we want to know which of the following systems of equations could represent the graph below. When we look at the system of linear equations, we recognize that these two lines intersect, and they intersect at the point 2, 1. Therefore, since 2, 1 is that intersection point, it is a solution to the systems of equations. That means when I substitute x equal to 2 and y equal to 1 in both equations, it would satisfy them simultaneously. So I could check each one of my equations, A, B, C, D, and E, in order to determine if 2, 1 is indeed the solution set. Looking at set A, I have the equation x minus y is equal to 3, and the equation 2x minus y is equal to 3. I want to see that 2, 1 simultaneously solves both solutions. Therefore, when x is 2, y is going to be 1. In the first equation, when I substitute x equal to 2, I get 2 minus 1. 2 minus 1, it gives me 1, which does not equal 3. Therefore, 2, 1 is not a solution to this system of linear equations. Because x minus y equal to 3 is not the appropriate line, I can eliminate choices A, B, and C because both of those have x minus y is equal to 3 in their systems of linear equations. So let's check D. In D, I have the systems of equation x plus y is equal to 3, and 2x minus y is also equal to 3. Again, I want to verify if 2, 1 is a solution to these systems of linear equations. When I substitute x equal to 2 and y equal to 1 into the first equation, I indeed get the true statement that 3 is equal to 3. Let's check to see if 2, 1 is a solution to our second equation in that system. Again, I will substitute x equal to 2 and y equal to 1 to check to see if that is indeed equal to 3. I have 4 minus 1, which also verifies that 3 is equal to 3. Therefore, 2, 1 is a solution to this system of linear equations. Let's just verify that 2, 1 is not a solution to the systems of linear equations represented in E. In E, I have the equation x plus y is equal to 3. I've already verified that 2, 1 is indeed a point on that line. It satisfies the equation when x is equal to 2 and y is equal to 1. I get the true statement 3 is equal to 3. When I have 2x plus y is equal to a negative 3, when I substitute 2, 1 into this equation, I get 2 times 2 plus 1, and that does not equal a negative 3, because a 5 is not equal to a negative 3. Therefore, 2, 1 is not a solution to the systems of linear equations represented in E. Another way that I could solve this problem is I could find the equation of both lines represented in the graph. To do this, I can identify 2 points on each one of the lines and find the equation. I know that in both lines, they pass through the point 2, 1, since this is our intersection point. Let's look at our first line that has a negative slope. I would see that it also passes through the point 0, 3. In order to find the equation of this line, I would find the slope, which is the change in y over the change in x. This is given to us by taking 3 minus 1, or the change in y, over the change in x, which is 0 minus 2. 3 minus 1 is 2, and 0 minus 2 is a negative 2, giving us a slope of a negative 1. We also know that our y-intercept is the point 0, 3, giving us a value of b being 3. Therefore, our equation is given by y is equal to a negative 1x, or a negative x, plus 3. Writing this in its general form, I could add x to both sides, having the equation x plus y is equal to 3. I can see that this is represented in both D and E. Now let's look at our second line, the line with the positive slope. I see that it passes through the point 0, negative 3, giving us our y-intercept, or our b value of negative 3. To find the slope, we would again do the change in y over the change in x, which is 1 minus a negative 3, all divided by 2 minus 0. 1 minus a negative 3 is the same as 1 plus 3, or 4 over 2, which gives us a slope of 2. Again, we already know that b is equal to a negative 3 because we have the y-intercept of 0, negative 3. Therefore, we have y is equal to 2x minus 3. Again, we are going to solve this and put it in its general form. I am going to subtract y from both sides and add 3 to both sides. Now I have 3 is equal to 2x minus y, which is represented in our system of linear equations in D. Again, verifying D is our answer.